Oh, man. That was fast. Wait, who's superposition? What was that? Nice. All right. So you're saying superposition. Okay. So when we do superposition, why do you want to do superposition? Why not just node voltage it? Yeah? Okay. Aha. So let's say you wanted to try and do node voltage. What would you run into here? There's two frequencies here, right? We got 10 and we got 100. So if we tried to use, so I'll write these up. 1 over j omega c, j omega l, c r equals r. So if we wanted to use this thing, right? We have two different omegas. So that seems bad. Can we still use phasors? The answer is yes. Why is the answer yes? There's a hint. Yeah, the guy's thing. He gave you a hint. Yeah, superposition, right? Exactly. So his hint was the answer. Just said it out loud. Cool. All right. So then what do we do? So let's say we replace. What do we do to this source to superposition it away? Short it, right? Yep. So it is a voltage source. And then we draw these guys and replace them by boxes. That's how you know. Yeah, I could do that, I guess. Yeah, that's a little too Eastern though, right? Doesn't it? A little spooky. Anyway, these Taoists had control. Anyway, all right. So the international Taoist conspiracy has led us to this point. So what do we do next? Yeah, complex impedances. Okay. So 1 microfarad. What does this thing turn into? So let's say ZC is what? Yeah, omega is what? Yeah, what's C? 1 micro. What do you want to do though? Yes. So then the whole thing ends up being what? Yeah, minus 10 to the 5th J. 100,000. Okay. Cool. Okay, and then this guy is easier because it's not 1 over anything. So what's he going to be? Yeah, 10 J. Okay. Yes. All right. So our goal is to find the voltage across this thing. What's one way we could do that? How do you guys want to do it? So we're trying to find, again, VL. So this is VL. So our goal is to find V hat L. Source 1, I guess. Of what? Okay, find the, yeah, okay. So I'm hearing muttering, so that's the fast way to do it. And that's true. So it would be basically, if we call this whole thing Z right, then I would call it Z right over what? 100 plus Z right times what? Yeah, so that's something we haven't done over here, right? What do we want to do with this thing? Yeah, so we'll just call it 3 angle nothing. Okay, so that's going to be times 3 angle nothing. Okay, so we have Z right. So how do we find Z right? So impedances, so I haven't said this explicitly a lot, but basically Z in series is just Z equals Z1 plus Z in, and then parallel is just like resistors. So it's 1 over Z. All right. Yeah, right? So 1 over stuff. Okay. So what's Z right going to be? I mean, you can just tell me how to write it out, and we'll do it a little faster. Yeah. So we can do the rule, like the little trick for We can do the little rule for two things in series or in parallel. We can just multiply them and then do their sum. If you don't know that trick, learn it. It'll save you some time, maybe. Okay. So, what's that? Why is it 3 angles 0? Because the phase, the offset on the cosine, so the magnitude's 3, and the offset, the phase, is 0, right? Because it's just cosine omega t. Basically, it's plus theta, so 0. Okay, so what is this thing going to be? What's 10j minus 10 to the 5th j, roughly? 10 to the 5th j, basically. Let's do some approximating, because we are engineers, and we don't care about that tiny 0.9. Okay. Over what? Yeah, negative, sorry. Okay, what's the top one? It's negative 10 to the 6th j squared, right? Yeah, hold on. So we got a lot of negatives. So these negatives cancel. This makes a new negative. This makes a new negative, right? So we have triple negative, right? Right, sorry. One. Yeah, 1. Yeah, so it should be positive, right? J squared's, okay, yeah. Let's just do it all, right? I mean, yeah, we can try and show off. It is 10j, but we can try and show off, but, we replace the j squared with minus 1. We get 10 to the 6th over minus 10 to the 5th j, right? But then when we promote the j up to the top, we get a minus again, right? So we end up with just 10j. Okay. It's kind of like, okay, am I happy with that? Is it really 10j? Yes, okay. Okay, so basically we have these two things in parallel here, and this one's, the magnitude is a lot smaller. So you guys may remember, right, if you take two resistors, like a 1 ohm and like a 100,000 ohm, in parallel they look just like the small magnitude one. The same thing holds true here. Take these two things, put them in parallel, 10j, roughly. Okay, so that's z, right? Okay, and so basically all that means that v hat ls1 for the left source is just going to be 10j over 100 plus 10j times 3 angle 0. Okay, so what do we do with this thing? Polarize it. Okay. So let's see. How do I want to do it? 10j. Okay, yeah. We could just divide out 10j. I think that's what I would do next, right? Yeah. It's a little 1 over 10j. Too many negative signs to keep track of. I'm going to be really lazy, right? Whatever. One way you can do it, there's a couple ways you can do this. One, do like divide by 10j over, divide top and bottom and polarize it, whatever. I mean, I did it this way, so I don't have to think about the minus sign at all. So 10j, if you just wanted to, just to see a different way, what would 10j be in polar coordinates? Yeah, 10 angle pi over 2. Why is that? Well, if you want, if you don't want to think in terms of formulas, in the complex plane, it just looks like 10j. So this angle is pi over 2, and the length is, of course, just 10, right? Okay, so 10 times pi over 2 times 3 angle 0, all over, what's the magnitude? The what? Yeah, 10,100, okay. And the angle is arctan of what?